Welcome all in the chapter design of three-phase induction motor. For today's session, we will solve a numerical. For today's session, we will solve the calculation of D and L for three-phase induction machine. The assigned question is determine the approximate diameter and length of stator core for a 11 kilowatt 400 volt three-phase 4-pole 1425 rpm delta connected induction motor, where they have given average flux density BAV, that is 0.45 Weber per square meter. Ampere conductors are 23,000. Full load efficiency is also given, that is 0.85, power factor 0.88, and L by tau ratio is equal to 1. So we'll take all given data, that is 11 kilowatt 400 volt three-phase induction motor for 4-pole machine. Also we are taking electrical loading, that is AC is equal to 23,000. Okay, sorry, here is printing mistake. It should be 23,000. Okay, ampere conductors per meter. The next given data is efficiency of the machine, that is 0.85, power factor 0.88, and average flux density 0.45. So let's start to solve this numerical. So for first step, we will calculate kVA input. The formula for kVA input is equal to output divided by efficiency into power factor. Okay, so we can calculate output. They have given output, that is 11 kilowatt divided by efficiency, that is 0.85, and power factor, that is 0.88. So our kVA input will be 14.7 kVA. Okay, so you can stop this video and you can calculate this ratio on your own. Then next step will be synchronous speed. We can calculate synchronous speed with the help of this formula 2F by P. So by solving this expression, 2 into 50 hertz frequency they have given divided by 4-pole machine, then you will get synchronous speed 25 rotation per second. Okay, so the next point, next we need to define winding factor, that is kWs. If they have given, you can take directly given value. If not, we can assume this value approximately 0.955. Okay, so this value we have assumed. Let this value so we can calculate next part, that is output coefficient. Output coefficient can be calculated with the help of this formula 11 into kW, that is winding factor, into BAV, which is nothing but average flux density, into AC ampere conductors, which is nothing but electrical loading. So this is BAV. This BAV is magnetic loading, this AC is electrical loading, and we can calculate with the help of this expression the value of output coefficient. So let's start to calculate output coefficient C naught. C naught will be equal to 11 into 0.955 into BAV. They have given BAV, that is 0.45 into 23,000 into 10 raised to minus 3. So by solving this expression, you will get value of C naught, that is 108.7268. Okay, you can stop this video and you can calculate this all values. so it will be become 108. And also if there any problem in calculation, you can comment it. So the unit of the C naught is kVA divided by or by meter cube into RPS. You can get this unit from this equation, the equation of the output equation of the induction motor. Okay. So next we can calculate kVA input. kVA input Q can be calculated with the help of this expression C naught D square L NS. Okay, so with the help of this expression, we are already aware about the Q. We have also calculated C naught. We have calculated this Q here. We have calculated C naught 108.7268. And also NS is calculated in this step 25 RPS. So we can calculate this D square L. So D square L can be calculated with the expression you can see here, D square L is equal to Q by C naught into S. So D square L D square L is equal to Q divided by C naught into NS. So we can calculate with the values from the previous slide. This is 108.7268 into 25. So D square L will become 0.0054 meter cube. So they have given L by tau ratio is equal to 1. If they have given any another value, you can take that value for various types of cases. That is for a good power factor, economical design, overall good design, L by tau ratio will change. But for this expression, this numerical, they have given L by tau ratio is equal to 1. So we can take this L by tau ratio is equal to 1. So from L is equal to tau from this expression. So that tau can be calculated with the help of this pi d by p, because tau is nothing but a pi d by p. So put L is equal to tau is equal to pi d by p in this equation number 1. You can get the value of d square L. So d square L is equal to d square. We can replace this L by the value of pi d by p, pi d by p. So your expression will become d cube into pi divided by p is equal to 0.0054 meter cube. Okay, so from this expression you can calculate value of d by solving this expression, because we are aware about p and pi. So your value will, by solving this equation, you can get d is equal to 0.1902, and same by placing this equation into this second equation, you can get value of L, that will be equal to 0.15 meter. Okay, so we have calculated D and L. With this process, the unit should be meter. Okay, so approximate value of D and L are D is equal to 0.19 meter and L is equal to 0.15 meter. Thank you.